Hello, my name is Iago, and today I'll be presenting the work entitled Combination of Optical Character Recognition Giants for Documents Containing Sparse Text and Alphanumeric Codes. Let's start by the problem. Today, many companies and by machines, parts, or tools retain documents such as notes, receipts, forms, or function manuals, and they may find themselves in the need of digitizing these documents. The problem is that these documents usually present sparse text in a non-continuous way, and alphanumeric codes that don't configure a word that would normally be present in a post-processing method based on a dictionary. So, in order to assist with that problem, we propose a combination of several pre-trained OCR models, so it is possible to achieve better recognition without training new models. Our experiment starts with line-level segmented images that are input into different OCR engines. The output from these OCR engines are done online and combined so we get a final output. And with this final output, we evaluated character accuracy, word accuracy, and the number of edit operations needed to transform the identified text into the correct one. For the input data, we adopted two datasets, the FUNST containing 199 annotated forms and the SROI containing more than 900 annotated scan receipts. Here are one example of each. The OCRs that we explored were the Tesseract, Octopus, Kraken, and Calamari, all freely available under the Apache License 2.0. In special, for the Tesseract, three different versions of it were explored, the Stable, Legacy, and Alpha version. In addition to those, the OCR from the Google Cloud Vision API was also explored, but given its usage limit, it was explored only in the SROI dataset. Regarding the combinations, we explored the majority voting, ranking, and median string. The majority voting is the simplest combination approach. It consists of counting the output from all OCR engines for a given position as one vote. In this way, it is selected the character with the most votes as the correct one. The ranking is analogous to the majority voting, but instead of considering votes equally weighted, the confidence values given by the OCRs are summed to form a rank. It is selected the character with higher sum of confidence. Finally, the median string was newly proposed in this work in order to combine OCR engines. It basically works searching for a string between the group with the smaller sum of distances, and then it systematically varies all the characters in order to minimize the distance even further. In this work, the distance measure adopted was the left-sign distance, and this combination was also explored using or not confidence as weights. Finally, we presented many different results regarding all the combinations in our work, but the median string was the one that stood out as an effective method for combining OCR engines. It presented an improvement of 3.09% in character accuracy and 1.60% in word accuracy for the SROI. For the FUNST dataset, it was observed an improvement of 1.48 in character accuracy and 0.54 in word accuracy. Also, I would like to highlight that with this approach, it was possible to achieve better results by the combination of free OCR engines than the non-free Google Vision by itself. Well, that's all for now, and thank you all for your attention.